Hi, this session is on comparing and ordering fractions. And before we start this lesson, you need to revise some of these keywords and symbols because we'll be using these for this topic. So what I want you to do is write down each of these words or symbols. So we've got ascending, descending, lowest common multiple, and I've also got the lowest common denominator because both actually mean the same thing. And we also have the less than and greater than symbol. So for each one, just to recap, write your own definition and also provide an example for each one. Now, when it comes to comparing fractions and ordering them, so order means we either put them in ascending order or descending order, from smallest to largest or largest to smallest, depending on what the question asks you. And it's an important skill to know this, because sometimes in real life we do deal with fractions, and sometimes you want to know which fraction is actually larger. If we look at this first example, we've got 5 over 9 and 5 over 12. Now when it comes to ordering fractions and to figure out which one's bigger than the other, it's important to estimate first. Sometimes it's easy to estimate and you can see straight away which one's larger than the other. Other times it's not so simple and we have to figure out a way on how to do this. So if I gave you a simple fraction, if I had, for example, 1/3 and 2/3, because these fractions have the same denominator, we can clearly see which one's larger than the other. If I've got one piece out of 3 pieces and 2 pieces out of 3, I can see this one is smaller than this one here. And of course, we can show this in a diagram. And when drawing diagrams, you have to make sure the diagrams are the exact same size. A lot of students make a mistake when trying to use a diagram on a test, so just be careful. So if I want to show this visually, I'd have one piece out of 3 pieces, and here I'd have 2 pieces out of 3 pieces. And we can clearly see that this one here is larger than this one over there. But sometimes, like I said, fractions aren't as easy to see which one's larger than the other to order. So this example here, it's starting to get a little bit trickier because you notice now we have different denominators. And when we have different denominators, we have to figure out a way how to make the fractions, or how to make the denominators the same, basically. Now with this one, I want you to estimate which one's larger than the other. And this one isn't too difficult because we can see we've got the same numerators. So 5 pieces out of 9, I think will be more than 5 pieces out of 12. But to show it visually, with this one, we can visually see which one's larger. Now, sometimes, unfortunately, drawing diagrams is not that simple, and you have to make sure, if you look at these circles, they're exactly the same size, okay? If one was bigger than the other, then this would be inaccurate. And looking at this diagram, I can see 5/9 covers more than 5/12. So we were correct in estimating that 5/9 is a larger fraction than 5/12. We've passed halfway with this one here. And we know half of 9 is 4.5, so we've passed halfway. Half of 12 is 6, and we know 5 is less. So as an estimation, a good way to estimate is, have you passed halfway or not? And that can sort of help you figure out which one's larger than the other. Now you have to know how to do this without a diagram, and of course show working out. Estimating is a great thing, but you have to prove that you're correct. Okay, and we'll start with these 2 fractions here. The best way to compare fractions is all you have to do is make the denominators the same. And once you have that, you can compare them and see which one is larger than the other. Okay, so to make the denominators the same, we have to figure out what is the lowest common multiple or lowest common denominator. They both mean the same thing. And if you can't figure it out, then the quickest way is multiply the numbers with each other. So in this one, I think I'm in a hurry, so I'm just going to go 9 times 12. What you do to the bottom, you must do to the top. And here I'm going to go 12 times 9. And of course, what you do to the bottom, you do to the top. That's the fastest way if you're in a hurry, but always try and figure out, maybe there might be a lower common denominator. All right, so we'll end up with the same denominators. 9 times 12 and 12 times 9 is the same thing. So we end up with 108 for both. Now that we have the same denominator, we can compare the top numbers. 5 times 12 is 60, 5 times 9 is 45. Now that we have the same denominators, we can now see which one's larger than the other. And it's definitely sure. 60 is larger than 45. And now that I've got my proof, we've got to insert one of these symbols, the greater than or the less than symbol. Okay, so because 60 is bigger than 45, I'll put in my greater than symbol. 60 is greater than, remember that bigger gap, it's greater than 45. Okay, and that's it. I've compared these fractions. First, I've estimated. I knew that 5/9 was larger because it's past halfway, but to prove that I was correct, I then had to make my denominators the same, and then I compare my numerators. And 60 and 45, well, 60 is way larger than 45, and I inserted my greater than symbol. Okay, so for our next two fractions that we're comparing, the question asks us which one is greater than the other, okay? Or which one's smaller than the other, same sort of thing. Now, to estimate this one, you can see this one's starting to get a little bit more challenging because half of 7 is 3.5, so 4 has passed halfway. And with this one, what's half of 3? Half of 3 is 1.5, and 2 is also past halfway. So a fraction like this, it might be difficult to get the right estimation. So I want you to have a guess, which one do you think is larger than the other? Okay, and now let's just prove that you were correct. So to do this, all we're going to do is make sure our denominators are the same. I'll just write it out again. So lowest common denominator, I think, will be 21 for 7 and 3. So I'll just times 7 by 3. What you do to the bottom, you must do to the top. And this side, times by 7, times by 7. By doing this, we now have the same denominators, which will be 21 for both. 4 times 3 is 12. 2 times 7 is 14. Now that we have the same denominators, we can clearly see which fraction is larger than the other. Which number is larger, 12 or 14? Well, we can see that 14 is larger than 12. So this one here is a larger fraction. So be careful when you put your symbol in. Okay, if we read from left to right, we're saying 12 is less than 14. Here's that smaller gap or that pointy part. 12 is less than 14. If we read it backwards, we say 14 is greater than 12. And that's it. That's how simple it is. Now for our next question, sometimes we can compare more than two fractions. And here we've got three fractions. Now this one, the hard work has been done for us. If you notice, looking at the fraction part, we've got 6, 6, and also 6. So the denominators are all the same. So we can just compare these. But be careful, this fraction here is what we call a mixed fraction. And this number 1, okay, so sorry, it's a long one. It's telling us that we already have one whole. So we've got one whole and then 2 parts out of 6. Whereas the first two fractions, they don't have any wholes yet. So straight away, whenever you see a mixed fraction, it should be an indicator that, in this case especially, it's the largest one because we have already one whole. So ascending order means, so hopefully you wrote your definition. So we're right, ascending means a rise or going up. So from smallest to largest. So this is the largest fraction, so I'll put it at the end. All right, now, out of these two fractions, which one, they have the same denominators, so it's done for us. Which one's larger, 3 or 8? Well, 8 is the next largest. And then we have the smallest one, which is 3 over 6. So this has been arranged in ascending order. With the questions like this, you don't have to insert the greater than or less than symbol. You can put commas just saying which order they are in. So remember, ascending is from smallest to largest. This next question is also asking us to arrange these fractions in ascending order. Okay, so if you want to write that question again, arrange in ascending order from smallest to largest. Now, if you have a look at this, we do not have the same denominators, okay? So we now have to make all three have the same denominator or the lowest common multiple. You can estimate, but you have to also show working out. Now, the best way, when you have three fractions, the best way to make them have the same, or the easiest way, you start with your bigger number. So 2, 3, and 4. 4 is my largest number. Is it possible to get both of these to turn into 4? Well, 2, yes. 2 times 2 is 4. But unfortunately, 3, no. Nothing times 3 can give me 4. Now stick with your largest number and let's think of multiples of 4 that 2 and 3 can both go into. Okay, so multiples of 4, well 4 times 1 is 4, we tried that. So we've got 4, next one is 8. 2 can go into 8 but not 3, let's keep going. 4, 8, 12. Can 2 go into 12? Yes. Can 3? Yes it can. So we found it. The lowest common multiple of these three numbers is 12. And that's the easiest way to do it. So just remember, always start with your largest number. Go through its multiples until both of them can go into 1. Now we've got to turn the 2, 3, and 4 into 12. So what is 2 times something to give you 12? Well, I know it's 6. And what you do to the bottom, you must do to the top. 3, I know that 3 times 4 gives me 12. And of course, same thing to the top. And I know that 4 times 3 gives me 12. Okay? And now let's multiply everything out and compare our fractions. So I know my denominators will all be the same. They'll all have 12 and 12. And now my numerators, 1 times 6 is 6, 2 times 4 is 8, and 3 times 3 is 9. Now that I have the same denominators, I can see which fraction is larger than the other. Now hopefully you had estimated, and maybe your estimation is correct as well. So from ascending order, so smallest to largest, the smallest one is 6, the next one is 8, and the next one is 9. So this one has actually been arranged for us. Okay, so I just put commas in. I don't have to rewrite it because 6 is the smallest, then 8, and then 9. So this question was done for us, really. All right, for our last question, we are comparing 3 fractions, and you notice that we also have mixed fractions. So this is 4 wholes there and also 4 wholes here. But do we all have the same denominators? Unfortunately, we don't. 3 and 3 are the same with these 2 fractions, but 9 is different. So when you have a problem like this and you have different denominators and a mixed fraction, you first have to change your mixed fraction to an improper one. Okay, if they had all the same denominators, then it's done for us. But unfortunately, in this case, we can't. So to turn a mixed fraction into an improper fraction, that's pretty easy. So then we go 9 times 4, which is 36, plus 4 is 40 over 9. Our next fraction, 15 over 3, we can see it's already improper. So they've already changed it for us. So it's done. This one here, we've got 3 times 4 is 12, and 12 plus 2 is 14 over 3. Okay, and now you should know what to do next. All we're going to do is make sure we have the same denominators for all 3. 2 are done for us. And go to the largest denominator, which is 9. Can I turn these 3's into 9? Yes. So this one's actually quite easy. 9 can stay the same. I know 3 times 3 is 9, and 15 times 3, don't forget that. 3 times 3 is 9, and what you do to the bottom, you must do to the top. And now multiply everything out, and let's see which fraction is larger than the other. So 40 over 9. 15 times 3 is 45 over 9. And then we've got 14 times 3, which is 42 over 9. Now that they all have the same denominators, which one's larger than the other? So let's arrange it once again in ascending order from smallest to largest. Smallest one out of 40, 45, and 42 is 40. The next smallest one is 42 over 9. And the last one is 45 over 9. And that's it. So the hardest ones you can get are ones like this, where you have to turn a mixed fraction into an improper one. And remember, when you have more than 2 denominators to change, in this case we had 3, always go to your largest one and start with the number itself. If it doesn't work, write down its multiples and see if the other numbers can go into it as well. Okay, so what I want you to do is to continue with some questions from your textbook. All right, so I just want you to go to exercise 4D on page 192 and just do questions 1 to 6 and also question 9. So you should get most of it done in class, and what you don't finish is that you need to do for homework. Thank you.